Hello, let's learn how to make some graphs for categorical data. I say learn, but you really already know how to do these things. You're just going to refine your techniques. The objectives for this lecture are to represent categorical data graphically, to know the required elements and standards of a useful graph, to avoid making bad or distorted graphs, and finally, to describe a categorical distribution from its graph. Let's begin with the example from last lecture, and my study of the most popular Starburst flavors. Here again are the results of my survey of 30 people. This is already telling, but pictures are real pretty, and they provide an intuitive understanding of the relationships between values and often need just very little explanation. There are lots of ways to represent frequencies or relative frequencies, but we are really fond of two of them, the pie chart and the bar chart. Let's start with the pie chart and begin with one simple rule. Don't make a pie chart by hand. It's far too difficult to draw these things accurately in any efficient way. So just don't. Now, what does a pie chart need? Well, it needs a title, legend, and clearly differentiated pie pieces. Here you can see my study displayed in a pie chart with all the required elements. You can differentiate the pie pieces whichever way you prefer. Your guidance should just be clarity. Now, somebody should be able to easily read your graph. Written labels can often help with this. Speaking of reading graphs, you describe the graph of the distribution the same way you did when all you had was the frequency table. What you want is to identify anything that helps answer your question of interest or tells the story of the individual studied. Some ways you might want to do this are to identify the most frequent value, least frequent value, and any trends you might see. Now, trends might include the graph is roughly uniform, where all the pieces are roughly the same size. Or maybe that just a few values are equally likely to occur. Most importantly, you want to discuss the graph in context. Don't say the pink piece is biggest and yellow and red are the same. Describe them for what they are. We are talking about flavors of Starburst, so that's how you should describe them. Now, based on this pie chart, I might say that pink is the most popular flavor of Starburst and someone is about twice as likely to prefer it to yellow or red. Orange is the second most popular flavor. Notice I did not mention the word pie, piece, or wedge once in that description. So when I say describe a graph in context, I mean talk about what the graph represents, not the graph itself. Up next, we have our good old friend, the bar chart. Here, the length or height of the bars represents the frequency or relative frequency of each value the variable takes. You can orient them vertically or horizontally, either is fine. So what are the required elements of a bar chart? A title for either the entire graph or each axis, appropriate scale on the frequency axis that starts at 0, labels on both axes, or you can use a legend, and your bars and bins should be the same width. Also, they should not touch each other. The most often overlooked and incorrectly applied requirement here is the scale, so let's examine that. You should always start at 0, and you should always give yourself a little bit of headroom, so make sure the tallest or longest bar reaches almost the top of the graph, but not quite. What if we want to make a relative frequency bar chart? Well, these should be proportionally identical to each other. They may not be perfect copies based on the scale you choose, but they will be proportional. Just like the frequency axis, the relative frequency axis starts at 0. Notice it does not go all the way up to 100% or 1. In fact, we often don't want it to. Just make sure you provide adequate headroom for the tallest or longest bar. And that's it. You don't have to create a graph in this course on a test, but if you do, make them quickly. You should focus more on the description of a distribution rather than drawing the image. And so now that you know what's required, let's make sure we identify some things you should avoid. Pictographs, 3D graphs, a frequency axis that does not start at 0. Okay, what are these things? Well, a pictograph is something that uses images other than bars to represent the frequency. The problem is, aside from being terrifying and incredibly unclear, pictographs like this one use icons that are not uniform in size. You see, our eyes respond to area, not just verticality. So whatever we are measuring in this graph, the relationships are grossly exaggerated because the clowns are simply blown up or shrunken down. The same is true for 3D graphs. Again, not only do our eyes respond to area, they respond to volume. The stacked imagery, the hidden bins, the depth, all distort the relationships between the values of the variable, making them difficult to read. And the final and most common bad graph is viewed as one of those ways we can easily lie with statistics. And that is when we set the frequency axis so it does not start at 0. Using a broken line can be okay sometimes when you're working with quantitative data, but we should never see this with categorical data. Here's why. At first glance, this graph makes it appear that someone is about 10 times more likely to prefer pink starburst than red. But this is representing the same data from my study. That the y-axis starts at 15% drastically over-exaggerates the relationship between the flavors. So always, always, always set your frequency axis to 0 when working with categorical variables. All right, that's it for this lecture. Here we discussed how there are many ways to graph categorical data, but the bar chart and pie chart are most popular. We discussed the required elements were things like titles, scales, labels, and legends, and we described graphs by trying to tell the story of individuals portrayed in context. And we discussed what to avoid in pictographs, 3D graphs, and offset frequency axes. Thanks for watching, and I will see you next time.